Dear students, let's start lecture number 17 on the topic wireless channels, types of wireless networks and ATM networks. This is our today's outline. First we will discuss ISM bands, 2.4 gigahertz, 802.11 channels, 2.4 gigahertz Wi-Fi channel frequencies, 2.4 gigahertz Wi-Fi channels availability, graphical representation of 2.4 gigahertz channel overlapping. Then we will be discussing 5 gigahertz channels and frequencies, 5 gigahertz channels allocation, and then we will be discussing types of wireless networks, advantages of wireless networks, examples of wireless networks as we have different kind of wireless networks available. Then ATM and ATM networks, ATM reference model, and then we will discussing benefits of ATM networks. Then I'll give you an assignment. Then I'll share my resources. Uh, you can explore those references to learn more about this subject. And then we will be having question answer session. So let's just get started with the revision of lecture number 16, which was on the topic electromagnetic waves. Electromagnetic waves, if you have seen oceans, you know waves. Electromagnetic waves or electromagnetic travels through space just like ocean waves that are created as a result of vibration. A vibration between electromagnetic and magnetic field. Waves are composed of oscillating magnetic and electric field. The energy carrying radio and TV channels, TV signals, the heat from microwave oven, the light from sun or X-rays, and gamma rays used in hospital are all form of electromagnetic waves. Their form might be different, but they share one common property that they travel at the speed of light in, a, in an empty space. Let's look at several terms of waves first, like crust and amplitude. A wave has a highest point called crust. As you, if you consider this as wave, so this is the highest point, so this is called as crust. A lowest point called trough, so this is the lowest point of wave, so this is called trough. The vertical distance between crust and the wave's center axis is amplitude, so this is called amplitude from the axis, and from the top, which is called crust, we call this as amplitude. Amplitude is about the strength of the wave or power of wave vibration or oscillation. So if you see the amplitude, you can say that this is the power of wave or energy of wave. Other word, the greater the amplitude of wave, the more energy it carries. So it also gives you the meaning that if you have greater amplitude, you can say that it carries greater energy. In wireless communication, amplitude means strong signal. We talk about amplitude, power, energy, and intensity are used interchangeably. So if you see power or energy or intensity, you can take as a meaning of amplitude. Now, wavelength. The wavelength is the distance from any point on one wave to the same point on the next wave. So here you can see that as this is, we are measuring from the, this is crust, this is the top point on the wave, and from another crust we call this as a wavelength. You can measure the wavelength from one axis, one lower point trough to next lower. So if you, this is, as you know, this point is called trough. So from one trough to the next we call this as a wavelength, uh, or 2 points on the axis. So this is one point on the axis and the second point, so this is also called wavelength. So you can measure the wavelength by using any of the three methods. By convention, we measure the wavelength from the top of a crust to the top of next one. So as I mentioned, you can use any of the method. The measure of unit of wavelength is meters. Normally, you measure wavelength in meters. Now, frequency. If we draw imaginary vertical line in space, like this line is drawn, and this wave is passing through this vertical line which was drawn in space, the frequency of a wave is how often a wave circle passes through the line within a certain time. Within, normally if you consider time, so we take 1 second. So in a 1 second, how many times this wave cycle is uh, wave cycles pass through this vertical line. So in 1 second, so we call this as a frequency. Number of times a wave cycle repeats within a certain time. Look at this wave. It repeats a cycle 3 times. As you know, this is cycle number one. This is cycle number one. This is cycle number two, and this is cycle number three. So as this is passes in this pass through this vertical line in a second, so we call this as a frequency. We use hertz to measure frequency. 1 hertz means a wave repeats one cycle within a second. Thus thus wave frequency is 3 hertz because it repeats 3 cycles per second. Now, relationship between frequency and wavelength. The wave with longer frequency has lower frequency, and shorter wavelength means higher frequency. They are inversely proportional to each other. Amplitude has nothing to do with frequency. Waves of different frequency can have the same amplitude. Waves of the same frequency can have different amplitudes. All waves of different frequencies travel at the same speed, the speed of light in an empty space, as we mentioned uh, before. Here you can see F is equal to C by lambda. So this is C is actually speed of light. So you can take it as 3 multiplied 10 raised to power 8. So this is lambda and this is F, which is frequency. So as we mentioned in previous slides, that frequency and wavelength, they are inversely proportional to each other. If you increase wavelength, so frequency will be decreasing. If you increase frequency, so wavelength will be decreasing. So frequency and wavelength are inversely related, as I mentioned. The lower the frequency, the higher wavelength. The higher the frequency, the shorter wavelength we have. Now, this was the first assignment, that as the wavelength of a wave in a uniform medium increases, its speed will. So these were the three options: increase, decrease, or remain the same. So the answer was remain the same. As a result of a wave in a uniform medium, its medium increases, its frequency will so decrease, increase, or remain the same. So this time the answer will be increase. The frequency will be increased. The speed of a wave depend upon, these were the four options, and the correct answer was A, the properties of the medium through which the wave travels. Now, electromagnetic waves. The whole range of frequency or wavelength of electromagnetic waves arranged in order is known as electromagnetic spectrum. As I mentioned in my previous lecture, it is classification of electromagnetic waves according to frequencies or wavelengths. It it is a range. It is a range of frequencies over which electromagnetic waves can propagate. It consists of the following waves: radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X rays, and gamma rays. So, radio waves. So these are the different kinds of waves. So radio waves, your radio capture radio waves emitted by radio stations, bringing your favorite tones. Radio waves are also emitted by stars and gases in space. Microwave radiation will cook your popcorn in a few minutes, but it also used astronomers to learn about the structure of nearby galaxies. Infrared night vision goggles pick up the infrared light emitted by our skin and and objects with heat. In space, infrared light helps us map the dust between stars. Visible, our eyes detect visible light, fire, fireflies, bulb, and star all emit visible light. Ultraviolet light rays, ultraviolet radiation is emitted by sun and are the reason skin tans and burns. Hot objects in space emit ultraviolet radiation as well. X-rays, dentists use X-rays to image your teeth, and airport security uses them to see through your back. Hot gases in the universe also emit X-rays. Gamma rays, doctors use gamma rays imaging imaging to see inside your body. The biggest gamma rays generator of all is is the universe. Is the radio wave the same as gamma rays? A radio wave completely different physical object than gamma rays. They are produced in different processes and are detected in different ways, but they are fundamentally different. uh, Radio waves, gamma rays, visible light, all other parts of electromagnetic spectrum are electromagnetic radiations. Electromagnetic radiation can be described in terms of a stream of massless particles called photons, each traveling in a wave like photon at the speed of light. Each photon contains a certain amount of energy. The different types of radiations are defined by the amount of energy found in photons. Radio waves have photons with low energies. Microwave photons have a little more energy than radio waves. Infrared photons have still more than visible ultraviolet X-rays and the most energetic of all gamma rays. You can see through this diagram, like we have a different kind of waves available here, like from these are the radiation type, and these are radio wave, microwave, infra, visible, ultraviolet, X and gamma. And here these are the different wavelengths available, and here we have frequency. You can see that as they are inversely proportional, so both are shown here, whichever you use. But if in the paper, if they ask you to tell us the wavelength of radio wave, so you have to write this one. Otherwise, if they ask you the frequency, so frequency is this one. So you have to consider both, but as they are inversely proportional, so you can take them in consideration. So wavelength decreases, frequency increases, energy increases. So this is the uh, main crux of this slide, that they are inversely proportional and they are showing all different kind of waves which are available in electromagnetic spectrum. All electromagnetic radiation move at the speed of light, as we know. So you can see the 3 million second in a vacuum. Here you can see that microwave, gamma rays, and radio waves are of electromagnetic radiation. As we know that all these are the type of different kind of waves. Electromagnetic consists of oscillating electric and magnetic fields. Light in a vacuum always move at roughly 3 million seconds. So this was the answer of the objectives or the fill in the blanks which I asked you in my previous lecture. So let's start our today's lecture. So our today's topic, actually we have three different topics: wireless channels, types of wireless network, and ATM network. So let's start with ISM band. Stands for industry, scientific, and medical. This is ISM stands for. Normally we call it ISM band. So Wi-Fi uses this unlicensed spectrum. There are a number of unlicensed spectrum bands in a variety of area of radio spectrum referred to as ISM band. The main band uses for carrying Wi-Fi are those on the table below. You can see here that we have this on the top we have lower frequency in megahertz and upper frequency in megahertz. So we have 2400 megahertz and 2500 megahertz. So this is the lower frequency and this is the higher frequency. You may call this is a range. So uh, often referred to as 2.4 gigahertz band. This spectrum is the most widely used of the bands available for Wi-Fi. This is the most important and widely used band, used by 802.11b, G and N. It can carry a maximum of three non-overlapping channels. Now we have another one that is of 5 gigahertz, and the range is lower frequency ranges 5725, and the upper frequency ranges 5875. This 5 gigahertz band or 5.8 gigahertz band provides additional bandwidth. Being at a higher frequency, equivalent costs are slightly higher, although usage and hence interference is less. It can be used by 802.11 A and N. It can carry up to 23 overlapping channels, but gives a short range than 2.4 gigahertz band. 2.4 gigahertz or gigahertz of 802.11 channel. There is a lot there are a total of 14 channels defined by Wi-Fi for the 2.4 gigahertz ISM band. I'll show those channels on my next slide. Not all channels are allowed in all countries. So they, some countries they allow you and some countries there is some restriction on them. uh, the WLAN or Wi-Fi channels are spaced 3 megahertz apart. The 802.11 Wi-Fi LAN standard specify a bandwidth of 20 megahertz, and channels are on a 5 megahertz incremental step. I'll show on my next slide. The 20 megahertz bandwidth and channel separation of 5 megahertz means that adjacent channels overlap, and signal on adjacent channel will interfere with each other. The differences occur in the RF modulation scheme is used by WLAN channels are identical across all the applicable 802.11 standards. The table on the next slide show the frequencies for the total of 14.802.11 Wi-Fi channels that are available around the globe. Not all these channels are available for use in all countries. So here you can see that we have total 14 channels. This is the lower frequency range frequency, and this is upper frequency, and this is, you may call it, central frequency. So if you remember this one, 2412, so if you add 5, so you will get this one, and then you will add 5 and you will get this one, and so on. So you can remember this by adding 5 to each to get 5 to get the next channel center frequency value. So if you add 5 to this value, you will get this one, and if you add 5, you will get this one, and so on. So this way you can remember. If you remember this one, you can remember all of these. So we have 14 channels, and these are the lower and upper frequency ranges of each channel. Now I'll show you that where they are available on next slide, like in this way. 2.4 gigahertz Wi-Fi channel availability. In view of difference in spectrum allocation around the globe and the different requirement for the regulatory authorities, not all the WLAN channels are available in every country. The table on the next slide provide a broad indication of the availability of different Wi-Fi channels in different part of the world. So you can see here that these are the channels, different channels available in 2.4 gigahertz frequency, and this is there. You can see in Europe, this is North America, and this is Japan. You can see that all of the channels available, but channel number 14, this is not available in Europe, whereas this channel number 14 is limited uh, uh, limited in North America, where in Japan you can use all these channels, but in channel number 14 you can only use 802.11b here. The rest of the flavors, they are not available in Japan as well. Graphical representation of 2.4 gigahertz band channels overlapping. You can see this is the overlapping of 2.4 gigahertz band. So here you can see that channel number 1, channel number 6, and channel number 11, they are non-overlapping channels. Okay. And one important thing, that why we are studying this channel selection, because selection of a proper Wi-Fi channel can significantly improve your Wi-Fi coverage and performance. So this can affect both your coverage and performance. So this is very important that which channel you are selecting. So these are different channels. Rest of the channel, they are overlapped channels, but these are the channel number 1, channel number 6, and channel number 11. They are non-overlapped channels. Now, 5 gigahertz Wi-Fi channel and frequencies. So all 25 of the available 5 gigahertz channels are non-overlapping at 20 megahertz wide, but gives a short range than 2.4. So this is the range of 5 gigahertz. This is shorter than 2.4 gigahertz. The 5 gigahertz band is divided into several different sections, like you may call it unlicensed national information infrastructure, UNII one. So these are the different channels like 36, 40, 11, 44, and 48. Now we have another one like UNII 2A, 52, 56, 60, and 64. and then we have UNNI 2C extended 100, 104, 108, and 1112, 112, 116, 120, 124, and 140, 144. UNNI 3, so 149, 153, 157, 161, and 165. These, the channels were spaced 20 megahertz apart, thereby providing non-overlapping channels. So they are actually non-overlapping channels. No overlapping is available, but their range is shorter than 2.4 gigahertz. Now I can shows these channel in different sections, like how they are bifurcated. Like here you can see that UNII 1. So these are the channels which I listed in my previous slide. Now this is the graphical view of the previous slide. So these are the channels which are available. They are non-overlapped channels. So DFS channels, you can see these are the weather radar channels, and then we have UNII 3. So different channels available here. You can see here that this is 20 megahertz apart, and then they clubbed two, like these two are clubbed, so now this is 40 megahertz channel each, and this is 80 megahertz. So in this case, these two are clubbed again, and you will get the 80 megahertz each. Now you have two, and then you have these two are clubbed, and now you have 160 megahertz. So you can see here now the total number of channels. This is one, but the total range is 160 megahertz. Now, come to types of uh, wireless network. So, WLAN, wireless MAN, and wireless WAN. So, wireless LAN connect two or more network devices using wireless distribution technology. Wireless mean connect two or more wireless LANs spreading over a metropolitan area. Wireless WANs connect a large area comprising LAN, MAN, and personal area network. So I think you can understand these. Like we already studied these in our previous lectures as well. So you have LAN. So as you see that the area wise, this is very limited as compared to this one. So this comprises of some, you may call it this, for example, you have different kind of labs, and this is in cities and this is in countries. So this is how we distinguish that where which network is applied. So this is, you may call it, this is in the organization, this is in the cities, and this is in the country, or uh, country, between the countries, or within a country. Advantage of Advantages of wireless network: it provides clutter free desk due to the absence of wires and cables. So most of the time this is are the most important benefit of wireless network, that you do not need wires and cables. It increases the mobility of network devices connect to the system, since the devices need not to be connected to each other. So you can connect them any, you can move them. They normally give you a mobility, you can move anywhere and you will be connected to your network. Accessing network devices from any location within the network coverage or a Wi-Fi host becomes convenient, since laying out cables is not needed. Installation and setup of wireless network are easier. uh, New devices can be easily connected to the existing setup, since they need not be wired to the present equipment. Also, the number of equipment that can be added or removed to the system can vary considerably. Since they are not limited by the cable capacity, this makes wireless network very scalable. So you can add as many devices as you want to wireless network. Wireless network requires very limited or no wires. Thus, reduces the equipment and setup costs. So this is one of the advantages of wireless network, that your cost is less than, as far as media is concerned, your cost is less than the wired network. Example of wireless networks. So you have mobile phone networks and wireless sensor networks. We will be studying each one of these in our next lectures. So wireless sensor network, satellite communication network, terrestrial microwave network. So we will be discussing each of these in our coming lectures, but these are the examples of wireless networks. ATM and ATM networks. So ATM stand for asynchronous transfer mode. It is a switching technique that using time division multiplexing for data communication. So normally is ATDM, asynchronous time division multiplexing actually. So ATM networks are connection oriented network for for cell relay that support voice, video, and data communication. They are connection oriented, means that, for example, if sender wants to communicate with receiver, so they both will be connected first before starting communication. It encodes data into small fixed size cells so that they are suitable for TDM and transmit them over a physical medium. So there is a fixed cell which is used to send over a network to the destination. So the size of an ATM cell is 53 byte, 5 byte header and 48 byte payload. So this is, you may call this the division of the packet, that 48 byte payload or data and 5 bytes of header normally used for sending ATM cell or a packet over the network. There are two different cell format: user network interface and network interface. So for example, if a user sending to the devices, for example, as you know, that if sender wants to communicate with receiver, so within sender and receiver you have some routers, like suppose. So if user or a sender sends its data to the receivers, first it reaches to the router. So the interface between the your device and the router is called user network interface, and one router is connected with another, so the interface between these two is called network interface. uh, the below image represent the functional reference model of the asynchronous transfer mode. I think you remember reference model of OSI reference model or a TCPI model. Uh, ATM has its own reference model. I'll show that. You can see this is the reference model of ATM, like you have ATM endpoint, ATM switch, and ATM endpoint. So this is sender, this is receiver, and how this is linked with the physical medium. I'll explain on the next slide. These are actually the advantages of ATM networks. It provides dynamic bandwidth that is particularly suited for bursty traffic. Since all data are encoded into identical cells, data transmission is simple, uniform, and predictable. A uniform packet size ensures that the mixed traffic is handled efficiently. So in such kind of network, your cell size will be same, as we studied that we have normally 53 byte, 48 byte of our payload, and 5 byte of our header. So each cell will be of same size. Small sized header reduce packet overhead, as the packet size as compared to TCP/IP or another packets. The header side is minimized in ATM, and because of this, most of their you may call you the header uh, is reduced. So what it does, that the extra burden of or extra burden on your network is reduced, thus ensuring effective bandwidth uses. So your bandwidth, for example, if you are sending 5 bytes, so it will be taking 24 byte as your header, and as compared to TCP or other packets where your header size is bigger, so it will take most of your bandwidth. Most of your bandwidth is taken by your header. So as ATM header is reduced to 5 byte, so your this overhead is reduced, and now most of the bandwidth will be used by your payload. ATM networks are scalable both in size and speed. Now these are the reference model, different types, like we have, you can see here, these are the different three models, like ATM endpoint. So ATM response model comprises three layer. Physical layer, this layer correspond to physical layer of OSI model, like we have a physical model, physical layer in reference model, we have the same in ATM reference model. At this layer, the cells are converted into bit streams and transmit over the physical medium. So what is the task of this layer? That it will take bytes and convert data into bytes and send over the physical medium. This layer has two sublayers, PDM sublayer, physical medium dependent, and transmission convergence sublayer. So this physical layer is divided into two. So this PDM layer, actually what this does, this is convert the bit stream, uh, convert the packet into bit stream to transmit over the physical medium, whereas the transmission convergence converted to set to the convert the data to the uh, cell to pass to the next layer, which is called ATM layer. This layer is comparable to data link layer of the OSI model, reference model. It accepts the 48 byte segment from the upper layer and add a 5 byte header to each segment and convert it into 53 byte cell, as we have studied in our uh, previous slide. This layer is responsible for routing of each cell. Traffic management, multiplexing, and switching is the job of this layer. ATM adoption layer. This layer corresponds to network layer of OSI model. It provides facilities to the next packet switching network to connect to the ATM network and use its services. This is like a network layer of network layer of OSI model. It accepts the data and convert them into a fixed size segment. The transmission can be fixed or variable data rate. This layer has two sublayers: convergence sublayer and segmentation and reassembly sublayer. ATM endpoint. It contains ATM network interface adapter. Example of the endpoint are workstation, routers, codecs, and LAN switches, etc. ATM switch. It it transmits cells through the ATM network. It accepts the incoming cells from ATM endpoint or another switch NNI update cell header, transmit cell towards destination. So these are the resources which I have used in making these slides. So you can go through each and explore more about this topic. And uh, this is your today assignment. The you have to submit application of 2.4 gigahertz and 5 5 gigahertz technologies with pros and cons of each, and then submit practical applications of ATM network, that where we are using ATM network, and what is the benefit of using these network, as I have discussed in my previous slides. So if you have any question, I'll be more than happy to answer all those questions. So if you have questions, you can ask me uh, through KCMS or WhatsApp group, or you can email me. I'll be more than happy to answer those questions. So thanks. With that, we reach to end of this lecture. Till next lecture. Allah Hafiz.